Hello students, today we are going to discuss about continuation of genetic disorders. In this last class we studied about that the autosomal disorders and now sex-linked disorder. Genetic disorder. In this sex-linked chromosomal disorder, there is Klinefelter syndrome. In Klinefelter syndrome, one type of trisomy, one type of aneuploidy, the number of chromosomes present in Klinefelter syndrome, that is 47. Here 44 autosomes plus XXY. That is total 47 chromosomes are present. It is trisomy. The addition of one X chromosome. That's why the characteristic feature of that particular male is called as gynecomastia. That means by adding of one X chromosome, some female characteristic features, that means developing of mammary glands and pubic hair growth, such type of characteristic features. Apart from this one, there is azoospermia. So these particular human beings are sterile nature. Then Turner's syndrome. This Turner syndrome normally affected related to female only. Here 44 autosomes as well as X0. That means loss of one chromosome, X chromosome. Already I said last class, loss of one chromosome called as monosomy. In this monosomy, Turner syndrome normally affects female organisms. In this female organism, normal symptoms are underdevelopment, that means the rudimentary development of ovary, menstrual cycle completely absent, there is no growth of mammary glands. Then apart from this one, the height of that particular baby less than 5 feet and webbed neck. These are characteristic features. Finally, this particular female individual organism, individual human being also sterile in nature. Then super male. In this one, 44 autosomes XYY. This is related to trisomy. The number of chromosomes are 47. Because of addition of one Y chromosome. So, due to maximum secretion of testosterone, the height of that particular individual becomes too height and all. This abnormal, but this particular male individual, that person become as a fertile organism. Both are sterile, but this is fertile one. This XYY, otherwise we called as Jacobson syndrome or the criminal syndrome. Maybe last class I said XXY we called as Jacobson. No, please consider here XYY we called as Jacobson or criminal. There is no any particular name here. Please rectify this one. Jacobson syndrome or criminal, that is XYY or XYY. That is also super male only. Either minimum 47 trisomy, tetrasomy, like this condition. Then super female, 44 autosomes plus X. One extra X added in trisomy condition, or here 47, here 48 or 49, like this. But these particular female organisms also fertile organism. But because of that morphologically, physically, that particular organism, that particular human being becomes too elongated, broader. Regarding related to normal people, they are present. Regarding to related to normal people, these people that morphologically, physically, little bit stronger one. Then, in exam point of view, what is this particular XXY? It is present. That is extreme Klinefelter syndrome. What is the genotype of extreme Klinefelter syndrome? Then your answer XXY. That is the normal Klinefelter syndrome. If they ask such type of question, extreme Klinefelter syndrome, then you write one more X. That is, it represents extreme Klinefelter syndrome. If it add one more, that is also extreme. If you add Y, but what is the name of such type of genotypic characteristic feature? It is also normal Klinefelter syndrome. The number of chromosomes becomes increased, but it is a Klinefelter syndrome. But it is extreme Klinefelter one. It is also XXY or XXYY also Klinefelter syndrome. So this is related to sex-linked chromosomal disorder. Then Mendelian disorder. Then related to Mendelian disorder, that is a gene mutation Mendelian disorders, or gene related human disorder or Mendelian disorder. In this one, autosomal. In this related to autosomal Mendelian disorder. So all these particular chromosomal, either autosomal as well as the X-linked one, normally may not affected from parents to children. Very rare cases there may chance. But this Mendelian disorder, frequently there may chance to transfer from parents to young ones, parents to offspring. Then autosomal recessive one. But according to NCR textbook, they have given sickle cell anemia, also autosomal recessive disorder. But according to present new one, according to new books and all, they have given that sickle cell anemia related to codominance. That is 1:2:1. The ratio of codominance 1:2:1. But they have given textbook that is related to sickle cell anemia. In this sickle cell anemia, already to change the sixth position of protein in that translation process, then to convert into that sixth position of that particular amino acid, particular that triplet base pair, it changes into the another one due to mutational. Then it is possible. Like this one, normal hemoglobin. In this one, normal HbA gene, it contains that cytosine, thymine and cytosine in that mRNA. Then after translation, it is formed guanine, adenine and guanine. It represents glutamic acid. It represents glutamic acid, like this continuously, like valine, like histidine, like leucine, threonine, proline, this particular one, glutamic acid, then one more glutamic acid. It is normally present like in that sixth position, in that normal hemoglobin, that AZ, if it is normal, that is normally it will be translated here GAG. In that translation is present, the person who affected that sickle cell one, that is sickle cell gene. If you observe, that sickle cell gene, it is present CAC. This as usual it will be present like valine, histidine, leucine, like a threonine, like a proline. Here, guanine, uracil, guanine, that means valine. Here it will be changes. Then again, glutamic. So in that sixth position, due to mutational changes, that sickle cell gene S, normal gene A, it replaces, then it causes sickle cell. This sickle cell, whomever will slow that particular area of the people, normally it affects and then according to environmental changes and these were, instead of normal shape of RBC, that is a circular biconcave shape, but it is sickle shape, that abnormal shape. Similarly, the abnormal function also takes place and all. This is normally, it will be affected. In this one, like HbA and HbA, this is the normal people. This is the carrier and all. In this one, no one affected. If both are carriers, what is the possibility? There may be a chance to affect any one among the offspring and all in the sickle cell anemia. Then related to along with this one, alkaptonuria, the continuation. Another recessive disorder, alkaptonuria. In this alkaptonuria, due to absence of one particular enzyme, that is homogentisic acid oxidase enzyme, due to absence of homogentisic acid oxidase enzyme, whenever that genetically mutational and this enzyme absent, normally this enzyme break down that alkaptin, it must break down. If this enzyme is absent, the alkaptin as it is present. Then alkaptin is deposited, different types of, normally this enzyme secretes from liver, normally it secretes from liver, as well as is also present in kidneys also, majorly liver. In that alkaptin, if it is present inside the body, it is deposited into the kidneys and form like a stone-like structure. So it may be leads to the that particular crystals, it may forms as stone-like structures, as well as that chondrias, that means in bone, related to bone, in that chondrial region and all, if it is deposited, it may be causes arthritis. So if alkaptin does not break down, if it is present inside the body, then it may be forms stone-like structure inside the kidney. There is a renal problem. As well as in chondrias, that means chondrial bones. Then like the terminal part of the nose as well as ears, that part, then it may be excessively present, there may be chance to arthritis. Normally, physically, it must observe that external ear as well as nose strip look like a dark in color. As well as it also excrete in the form of urine. After excretion of urine, it becomes very dark color, that means very black color by exposing of air and all. Excretion in the form of urine, it becomes dark by exposing of air and all. So urine becomes dark or black color, that person suffering from alkaptonuria due to this genetic mutation and all, due to absence of this particular enzyme. Then apart from this one, phenylketonuria. In this defective gene normally present in chromosome 12. It is present in chromosome 12 and all. This phenylalanine hydroxylase due to absence of phenylalanine hydroxylase. Normally, this phenylalanine hydroxylase, it break down phenylalanine into tyrosine. If it is not break down, it accumulate into the blood and formation of their product phenylalanine pyruvate, phenylalanine acetate, phenylalanine lactate, phenylalanine acetate glutamate, such type of products and all. As well as it excrete in the form of urine. Then apart from this one, hypopigmentation of the skin. Then the hair color, that means the mousy odor, their hair as well as skin and all. Mousy odor, either skin as well as hair. Apart from this one, it excrete in the form of the urine, phenylalanine, excretion in the form of urine. Normally this enzyme secretes from liver. If it is not, whenever that gene, that defective gene present on chromosome 12, unable to secrete this enzyme, then all these effects like eczema related to skin, it is also causes that eczema also one type of defect, also one type of disease. Also it affects, it causes and all because of this one. Then along with this one, then one more, cystic fibrosis. The defective gene in cystic fibrosis present on chromosome 7. It is present on chromosome 7. So earlier we called as mucoviscoides. So very carefully listen, mucoviscoides. So instead of cystic fibrosis, they may chance to ask mucoviscoides, in which this disease normally which chromosome defective gene may causes to the mucoviscoides. Then it is similar to cystic fibrosis. Mucoviscoides, otherwise it is called as mucoviscoides. So normally the CTT, these three base pairs, while these particular mutational changes of or deletion of CTT base pairs on the 7th chromosome, cytosine, thymine and thymine, these three are, if it is mutationally changes and all, then it may be causes dysfunctioning of or deformation of glycoprotein are formed. Then it formed deformation, glycoprotein, or disorder or deviation or regarding related to dysfunctioning deviation, deformation. That means it is not normally formed and all. So dysfunctioning of glycoprotein. That means dysfunctioning of glycoprotein. Whenever dysfunctioning of glycoprotein, it deposited, it affect on respiratory tract as well as gastrointestinal tract. That is important. Which particular organ system, that defective gene of chromosome 7 normally affected both respiratory as well as gastrointestinal tract and all. In respiratory tract, normally it deposited mucus because of failure of chloride transportation, that chloride function, that means excessive elimination from our body. Then mucus deposited on bronchial tubes, then very difficult to take the respiration. Similarly, that pancreatic ducts, if it deposited that mucus and all, it is difficult to secrete that pancreatic juice. Normally pancreas connected to gastrointestinal tract through duodenum. It unable to secretion to the duodenum and all. Then it is deviate, that means disturbance of that particular digestion as well as very difficult to take the respiration. Because of this particular deformation or abnormal, otherwise we call as abnormal, that glycoprotein, it may be causes deposition of mucus on bronchial as well as this particular pancreatic ducts and all. In this may causes both respiration as well as that gastrointestinal tract. That is very important, which particular chromosome and all, because of that particular glycoprotein. Next, there is Tay-Sachs disease. Normally, these defective genes, it is present in chromosome 15. It is present on chromosome 15 and all. That is already said, Tay one scientist, Sachs another scientist. Both scientists explained about these particular diseases. Explanation of the disease, how it is affected and all. This one, deficiency due to defective genes, that a particular deficiency, one particular enzyme and all. So, deficiency of enzyme. Deficiency of, that is hexosaminidase, beta, that is deoxynitrate acetyl hexose aminidase, complete name, or simply you write beta hexose aminidase. Because of the deficiency of this beta hexo, that aminidase, then it causes, normally it break down one particular sphingolipids. Beta hexosaminidase helps to break down sphingolipids. These sphingolipids normally we call as gangliosides. What is the sphingolipids? Gangliosides. More common ganglioside, GM2. Unable, whenever deficient, unable to break down. Whenever unable to break down, it deposit. Where it deposit? It deposit on brain, deposit on spinal cord. So that is gangliosides. This ganglioside, one type of the lipid, due to lack of this particular enzyme, it is present. It must deposit on brain as well as spinal cord. If it is deposited, then automatically mentally retardation. Normally, if it affected at the age of the 6th month of the baby, then within 3 to 4 years that baby becomes dying. that much severe effect because of brain and spinal cord due to deposition. This one GM2 glyco, that is gangliocytes and all, that particular nerve cells where it is deposited, they are related to abnormal eyesight also. Within 3 to 4 years, that particular, normally this Tay-Sachs disease normally affected Jews. These are Judaism, that is one type of the population. So Jews, Judaism, one type of the Judaism. This Judaism population, normally this disease, they must identify the Tay as well as Sachs and all. Then, what is meant by thalassemia? One more type of autosomal recessive disorder. Thalassemia. This thalassemia normally disorder, then disorder of reduced hemoglobin. Very simple, remember, disorder of decreased hemoglobin percentage. When it will be present under normally two types of thalassemia, alpha thalassemia, beta thalassemia. It is present alpha and beta. Alpha thalassemia defective genes, that means controlling genes, is present on chromosome 16. Beta thalassemia, it is present on chromosome 11. Among these two, which is the common type of thalassemia? Common type of thalassemia, then you write beta thalassemia, that is inadequate production of beta chain. Normally hemoglobin, formation of hemoglobin, alpha chain, beta chain is present. Among these chains, and while if it is defective genes present in beta thalassemia, that it may be causes, that means inadequate production of beta chain in hemoglobin, that is known as beta thalassemia. What is it by alpha thalassemia? Inadequate formation of alpha chain in hemoglobin, that is we called as alpha thalassemia. Among these one, more commonly present in the population, that is beta thalassemia, that means anemia type of the disease it affected, but it is not identified, but it must be commonly present under. In this beta thalassemia, that is one among this one major, another one minor. What type of genes are present? Beta thalassemia control two genes, that is the beta genes only. Alpha thalassemia, alpha genes only there are. It must be controlled 4 genes on 16th chromosome. Here 2 genes on 11th chromosome. In major thalassemia, both genes are affected. Both genes are defected. Minor, one among the gene defect, but externally may not identified. Asymptomatically present. This is a severe illness in that major beta thalassemia, otherwise we call it as Cool's, otherwise Cool's disease. That means severe illness apart from anemia because of that suppression of that particular chains. That means A, B, such type of chains under alpha chain, beta chain, gamma chain, delta, all these chains which suppresses. That's why severe illness and also causes and also present, that is anemia condition. It is one among this one. It is asymptomatic one, but 15% less than hemoglobin secretion, but asymptomatically present, but major only it identified. In this beta thalassemia major and along with alpha beta, it is also possible to formation of gamma, delta. It is also formation of gamma chain as well as delta chain also. While formation of gamma as well as delta and there is a formation of that hemoglobin F as well as hemoglobin A2. There is a separate additional chains. Whenever additional chains are formed, then unable to proper production of erythropoiesis, erythrocytes, production of RBC. Whenever excessive production of that gamma delta more than the normal amount, then one can kill that bone marrow cells. One can destruction of bone marrow. Whenever destruction of bone marrow, then reticulate cells becomes destroyed. That means improper, immature RBC cells may not be formed in a proper manner. That means improper maturation or improper development of or improper erythropoiesis. Because of this one, improper erythropoiesis takes place. But there is a remedy is there. What type of remedy? Normally once in 3 to 4 weeks or minimum 2 to 3 weeks, the blood transmission or bone marrow transmission, it must change bone marrow because of additional chains are formed due to destruction of bone marrow cells, unable to production of erythrocytes, abnormal production of erythrocytes and all. That is thalassemia. Then albinism, name itself represent tyrosinase, while absence of tyrosinase enzyme, normally this enzyme helpful for production of melanin pigment indirectly. Here hydroxy, this hydroxy, proline, that means phenylalanine or dihydroxy phenylalanine, this it will be supporting. So tyrosinase induces, that is dihydroxy phenylalanine. Indirectly it helpful for production of melanin pigment in the hair as well as skin and all. Then whenever this enzyme will be absent, then it may be leads hair, skin becomes too dull. That hair as well as skin become albinism. That means unable to production of that particular aspects. Why? Because the long chain of 11th chromosome, defective genes are present, while causes of this albinism, as well as that particular P gene present on 15th chromosome. Whenever defective that particular P gene present on 15th chromosome or long arm of defective gene present on 11th chromosome, then it may be leads to the albinism. That color may not be present, appropriate melanin pigment completely absent and all. Normally one can observe, it must observe European population. Then Gaucher's syndrome. This Gaucher's syndrome, that glucose cerebrosidase, absence of cerebrosidase enzyme, due to absence of glucose cerebrosidase enzyme. Whenever absence this one, certain lipids are accumulated into the brain as well as spleen as well as bone marrow and liver. All these particular areas as well as spleen, it must be deposited. Whenever deposited, defunctioning of organ systems. It may be causes to the defunctioning of organ system. That is autosomal recessive, that genetic Mendelian disorder and all. What are the autosomal dominant disorder? What is autosomal dominant disorder? In that Mendelian principle and